we are going to skip the top part and go right down here to number 2 to review yesterday's average value stuff. So we've got a function f of x, go put it in a box. We have two types of questions when we're dealing with average value, and these are from yesterday. Just to review, the average value of a function is a formula. I said yesterday to call that f sub av, or f of c. And we said that formulaically it was 1 over b minus a times the integral from a to b. The integrand is the function that you're finding the average of. For this one, it's going to be sine x, but I'm just going to write f of x dx. So whatever it says to find the average value of, that goes in here. If it says average velocity, velocity goes in here. Average acceleration, acceleration goes in there. So my function, from a to b, I'm going to do 1 over b minus a. So I will have 1 pith. I like to say 1 pith. From 0, it truly is 1 pith, right? Like if it was a 9, you'd say 1/9. So it's 1 pith. From 0 up to pi, I'm going to find the antiderivative or integrate sine x with respect to x. So this part right here is just my fundamental theorem of calculus, which says I do the antiderivative. So be 100% sure, do your St. Cloud, negative cloud, ends and starts the same, just so you don't make a sign error. You're integrating, so you're going up the ladder. So make 100% that you don't make a sign error. We'll have a negative cosine. So I'm going to put the negative out front of the 1 pith. I'm going to be having cosine x that I am evaluating from 0 to pi. And that's how you're supposed to write it. I have morphed it into this. I just like it better. But in college, you would see just that single bar. I like to bracket it off. Then I remember what we do with the fundamental theorem of calculus. We dump the top boundary in first. So I will have my negative 1 pith. And I will have cosine pi. Don't forget you subtract, you don't add. And I'll have cosine 0. Nothing new here. This is just reviewing yesterday just to make sure we've got that down. You need to be really confident in your unit circle. If you're not, make one. So I'm going to go make one. I'm comfortable with it. But if you need to think it out, better to draw it and have it accurate than have it off, because it'll throw the whole rest of the problem off. So head on over to pi. I'm looking for cosine over there. Cosine is x. So that's 100%. A negative 1. And what is cosine 0? 100%? 1. Yep. Boom. So barring any unforeseen arithmetic mistakes, which I haven't made, I have a negative 1 over pi times a negative 2, which gives me 2 piths. Put it in a box. What is this called right here that I just found? What did I find? What is it? Say it. Average value, right? What does it mean graphically? And I do think that's almost more important than getting the number. So because we didn't do this example up here, we're going to use this space to do a graphic of this situation so we can tie it all together. So in this space, we're going to do a visual of A and B. So we had this function, it was the sine function. The sine wave starts at 0, 0, because sine of 0 is 0. Sine of pi is also 0. Oops, sorry. And again, I'm just going to stay in this interval. Sine of pi halves is what? 1. It's the most the sine function can ever be. And I've got the sine wave going like this, but I'm only interested in this much of it. Goes like that. So let's revisit from yesterday again what that 2 over pi is. Can someone do 2 divided by pi on their calculator and give me a decimal? Because I want to know, I want a number that I can quantitatively look at. 0.64. So what 0.64 represents is the height of a rectangle. So this right here is about 0.64 or 2 over pi. Remember that the average value is the height of the rectangle that has what? Yeah, Same area as the area under the curve, and it's called the average value. Yes, there's some above, some below, but this is called the average value of f. So when we go to part B and it says find the value of c that's guaranteed by, and again I called it the MVT for integrals, but it's usually that you are guaranteed the place where you reach your average value, I mean. That happens twice here. Right here on the curve, I'm at my average value, and right here on the curve, I'm at my average value. So how many answers am I going to get for part B? How many answers? There are two places where I'm actually at my average value. Right here, I'll call it C1, and right here, I'll call it C2. I'm going to have you watch those two answers fall out as we go figure it out. So when I'm figuring out for what value of C, C is an X value, where I met my average value on F. Well, F's are the Y's, right? So here, I'm going to rewrite my original function. It was f of x equaled, it was just sine x. I want to know where I reach my average value. What was my average value? 2 piths, yeah. So I want to know when I was that high. So I'm going to replace y, or f of x, with 2 over pi. And I want to know when this happens. That you don't know off your unit circle because 2 over pi isn't on the unit circle. If that was 2, that was like 2 over 2 or a half or something, I could figure it out. But without a calculator, I'm now stuck. So I want to talk about how you solve this with a calculator. There are two ways. One is better than the other. Can you give me one way of solving that if you have a calculator in your disposal? Give me an idea. Anyone got one? What'd you say? Sign in versus how you were taught in pre-calculus, and that will certainly give you the answer, but I'll show you the fault with it. So we'll go do that because an answer will fall out. So if I sign inverse the left and sign inverse undoes sign, so I'll just get x, and if I go to my calculator, it will give me an answer. But the key to what I just said is it will give me an answer. And how many answers are there? 2. So then I need to either use some more of my pre-calc skills about reference angles and where it falls to go figure out the other one, which is a pain in the butt, or I can do it a different way. But I want to get this answer. So can somebody take out their calculator and sign inverse that sucker for me? Thank you. That is one of the values that C could be. That's one of them. And let's go back up to our graphic and put that on there. That's this one. So that means right here is the point 0.69 comma 2 pi. That's where I reached my average value. But I can so see that there should be another answer. The problem is your calculator can't, with its syntax, spit out two answers at once. So it gives you the first one, right? So the problem is, how do you get that one? And I don't want to spend 15 minutes reminding you of all the pre-calculus you forgot for how to get the other one. Fair enough? So what we're going to do is say, yes, this does give me an answer, but I'm never going to do this again. Because in this class, for me to avoid having to remind you of how to solve all different kinds of equations, it's better for me just to have one approach. And do you remember what that is? Always, yes. Subtract and get one side equal to 0, go graph it and calc 0. And by it, that can be any function, no matter how ugly it is. If you take the original, remember what I'm trying to solve. I'm going to rewrite it again. I'm trying to solve this for x. What I'm going to do is get one side equal to 0. Doesn't matter which. You can do sine x minus 2 pi or 2 pi minus sine x. Either way. Now, this, you will go, this could have been 2 over pi cubed minus e to the sine x divided by 1,000,000. And as long as I can graph it, and it's a function that has a 0, it will hit the x-axis, and that's my answer, right? Because that's when, if you enter these under the y's, the x-axis would be where y is 0, and that's what you're looking for. So go to your graphing calculators and enter under y equals 2 over pi, and there's one really ugly one on your worksheet that's calculator active, and you couldn't care less how ugly it is. All you've got to do is type. So go type this into your calculator. Before you hit graph, because it's got a trig function in it, you don't want to have to manually alter windows, and your calculator's been programmed so that you rarely should need to. If it's a trig function, what did I tell you to hit before you graph it? Do you remember? Zoom 7. Yeah, Zoom 7 it. And what you're going to do is your calculator will then lay this out as if it's going around the unit circle. It'll start at 0, it'll go up to pi halves, then it'll go to pi, then it'll go to 3 pi halves, and then it'll go to 2 pi. So it makes one full circle of the unit circle as its graphing grid. We are concerned with from 0 to pi. And if somebody could bring their calculator up here because I am tied with my cord, do you dare throw it? I wouldn't either. I just want to. Oh! She dropped it. Oh, no. I don't think it'll be broken. Okay, one more. Don't throw it. You didn't throw it at me, did you? Because I'm like, did I not catch it? Okay, great. This is all on recording, too. I just want anyone listening to this know she did not throw the calculator. It slipped out of her hands. Anyway, so it came like this, and then it went down here, boom, and then like that. So you can see here, you can have that back on. I'd hand it to you, but I'm plugged in. I'm chained to my computer. So you can see I've got 2 zeros right here. I knew I better, right? Because I knew I was going to get 2 solutions. Again, just to review, how do you find where these are using your calculator skills? What do you do right there? Calc 0. Yeah, so you're going to go Calc 0. It should be of no shock to you what you're going to get for the first one. I'll give you a minute to go Calc 0, the first one, but honestly, that one I don't need. Because what's it going to be? It's the one I found doing the inverse functions. My calculator, again, when I did sine inverse, it couldn't spit both of them out. It would have required me to figure out with a unit circle where else there was an angle with that same sign, which is over here, which is pi minus this, and you'd get all goofed up. So, well, you're not going to do that. We're going to go Calc 0 on this one. What was the second one? 2 point something I remember from last hour. 415? 451. All right, so one more time back to the graphic so we don't lose track, because this is a lot. It looked like somebody puked up a bunch of trig on my grid here, but there's a lot of stuff going on. You just found this one to be 0.69 and this one right here to be 2.541, whatever. I'm just going to leave it. There they are. This again is the average value. It's the height of the rectangle. When it says find the C, it's where is it that height? You usually have one answer, but this one had 2. So that's old stuff from yesterday. It was a good problem to review it though. I like it a lot. All right. Oh, I shouldn't talk like that when I'm in. All right. Anyway, sorry. I'm going to get squirrely on video. And it's early too. That's why I never record this hour. I usually record 1st or 5th because I get all weird. All right, by the end of the day, because it's like my 5th time doing, actually 3rd, I'm exaggerating, but anyway, we got something new coming at you, the second fundamental theorem of calculus. I could just tell you, you would do it correctly, but I like to show you why you're doing what you're doing. So I'm going to do it the long way once and then say don't ever do it like that again, because this says there's a shortcut. So this is what we're going to do. We're going to take this right here, and we are going to integrate it using what we already know. The fundamental theorem of calculus says antiderivative, t cubed over 3, 4t squared over 2 plus t is the antiderivative of that integrand. I am going to evaluate it from 1 up to, oh, psych, not a number, a variable. Process does not change though. I still dump who in first? Yep, x. Top one falls in first, and t gets replaced and becomes x cubed. This becomes 2x squared plus x. The bottom one's going in, and it's going to give me a number, which would be 1/3 when I plug it in, minus 2 plus 1. And I don't care what that number is, so I'm not going to waste time finding it. I don't care what it is because what I'm going to tell you to do next. It says now take the derivative of your answer. So watch, I'm going to now take the derivative of this. So remember, derivatives, power out front knocks it down 1. So this becomes 3x squared over 3, or just x squared. This becomes 4x to the first, and the derivative of x is 1. Why didn't I care what this was? Yeah, it's a constant, so its derivative is 0. Now it says what just happened in that process. Box this in. travel up here and box this in. What do you notice? They're the same, with one minor difference. What's the difference? A variable change. Exactly. So what happened, my basic result, was I got the exact same integrand, but exactly what you just said, with a var change, a variable change. Let's talk about why that happens even before I give you the theorem. Okay? It happens because I integrated and then I took a derivative. And what are those operations? Inverses. It's like me telling you square this and then square root it, or add 5 and then subtract 5. Inverse functions undo each other, and you do get your original right back at you. So it should be no shock to you that I performed an operation called integration, and then I did the derivative of my answer, which undoes integration, and it pooped out the exact same thing I started with. And it should make sense why there's a variable change. It came right here because my top was a variable. It dumped in and replaced all the t's, right? So this is what the theorem says with taking my words and putting into a theorem base right here. It says if you take the derivative of an integral from a constant, and that's worth pointing out, it does need to go from a constant because remember that caused that whole bunch of stuff to disappear when I took the derivative. Because what's the derivative of any constant? 0. All right, so it says when you take the derivative of an integral of a function, you get the exact same function back. The only difference is your variable t gets replaced. And again, these are just placeholders. So this could have said 0 to p of q of z dz, right? This is just the most formally used. The next part of it says and. This right here I want you to circle. U stands for, in this case, and what it's always stood for in here, some function of x. So it need not be just x. It could be 2x or x to the 5th or root 2x squared minus 1 or sine 9x or sine 2 pyths. I'm like, 2 pyths is my new favorite number just because I like to say it. Do you know when my birthday is? Right there. Oh, geez. Okay, I'm on, forget I'm recording. Sorry. My birthday's on Pi Day. How weird is that? I was born on March 14th. So you better bring me a pie on Pi Day, because when will you ever have a math teacher again in your life whose birthday is on Pi Day? Right? Now, how old will I be? Pi to the pi, no, just kidding, minus, I'm just kidding. All right, I'll continue. You guys are looking at me like I'm whacked out. What was I talking about? Oh, that what got me going right here. I was like, Lord, there was math that led to that divergence. Oh, it led me on a tangent. Ha, too funny. Anyway, see, there you go. What was I talking about? Okay, u was a function of x, and I said it could be sine 2 pyths, and then the pi, and then the birthday. There we go. What does that say? It says you can still put that whole function in and replace like right here, I can still just take this x squared and dump it in. The only difference is you have to multiply by du dx. What is that? AKA u prime, or the derivative of the guts, or the derivative of whatever that was. So watch how easy peasy the second fundamental theorem of calculus is. It's really easy. I only have you do 4 in your homework. We do them together. They take us 1 minute, and I don't have you practice it because I'm totally against practicing easy things. It doesn't make you better. But as long as I'm taking the derivative of the integral, I just dump it in. My answer, x squared minus 1. Could KK integrate that? Sure. Then take the derivative? Sure. She's going to end up with this, so don't do it. Fair enough? It will be this. We dump it in, and then we derive. I like to call this the dump and derive theorem, not the second fundamental theorem of calculus. All right, so I go to this one, and I go, oops, problem. What's the problem? What's the problem? My limits are backwards. Okay, well, we're going to use a property that was made legal last week when we said, go ahead, change them. You don't want it to go that way? Go this way. However, when you make that limit change, what did we also say you needed to do? Negative, yeah, there it is. So all me getting my variable on the top to dump in did is cause me to have a negative dump, okay? So I'm going to dump this in, and I get x sine x. And you might say, LaRude, what's happening to your du? What's the derivative of x? 1. What's the derivative of this x? 1. So when it's just x, it clearly is just about taking a dump. But when it's a function of x, you got to dump and then derive your dump. So this last one, I still am constant. That's good. Nothing fancy needed. I'm going to dump that right in there and call it cosine x squared. But if it's a multiple choice question, that is not what I'm going to circle because that has guts. It has a derivation that I need to put on there, and it's not 1. What's the derivative or du dx? 2x. That's my answer. So you might say, this is so easy. I hope there's a million of them on the AP exam. There will be a couple, but there's also going to be like the one you just glued into your composition notebook. So open that up, and I'm going to tell you what 9 out of 10 dentists pick for that one. Okay? It says the integral, and I forgot the constant on the bottom, so can somebody tell me once you open it up? From 0 to x, and it's sine t dt, right? All right, here's the problem. Because this looks so much like the second fundamental theorem of calculus, and because this second fundamental theorem of calculus is so easy, kids will go, I remember this one. You just dump it in, sine x, bubble a, and go, that was the easiest question. And this is a very, very low scoring type of question because that's wrong. Because that's not what the second fundamental theorem of calculus says. It doesn't say you get to dump numbers into integrands, right? We've never been able to dump stuff in. Why, for the second fundamental theorem of calculus, could I dump it in? Because I was taking the what? The derivative of the integral, which undid it. That's why. This doesn't say to take the derivative. It just says to do this. This isn't that question. You'll notice in the learning goal it says I know how and when to apply it. The how is easy, dump it in. It's the when that's tricky. I don't apply it here. I do it like this. What's the antiderivative of sine? Negative cosine. I do negative cosine t from 0 to x. I do negative cosine x minus, right? Negative, which is going to become plus, cosine 0. That's what I do. I get negative cosine x plus 1. Really, what should I be circling? I don't know because I'm not looking at the other. Is it E? E. What do you think? I bet probably, again, this is an international test, but I bet internationally, how many kids do you think pick A? Well over half. Well over, because it looks like this. That's why I like to show you why things are working, because otherwise you just do what, you know what I mean? And it feels good. You're like, oh, that was easy. Well, how could I make the answer just sine x? What could I add to the question? Either write in words, find the derivative of, or put d dx, and then I'm safe. See what I mean? So be very careful with that. What's up next is, I'm going to pause this for, we will do number 7. All right, so it says, find the interval on which this curve is concave up. Go put that in a box. This is an awesome question because it's testing lots of skills in one problem. First of all, back to chapter 3. How do we determine concavity? There it is, second derivative. What has to be true about the second derivative? For concave up, it has to be greater than 0. That's what I'm looking for. So this triggers my brain that I need to, whatever function they give me, I need to derive it twice. So I go back up here and I do dy dx. So really I will be taking the derivative of an integral, right? So y prime, the first derivative, what do I just do according to today's notes? What do I just do? Put the x in, dump and derive. When you take the derivative of this integral, they're going to undo each other. You're going to get this function right back at you, but the variable will change. So it'll be in terms of x, which is great because I want dy dx. So this is derivative number 1. Derivative number 2 would be 3x squared plus 2x plus 0. So then we have to remember back to chapter 3. Once we have our second derivative model, what do we make? Sine line. We make a sine line for the second derivative. Who goes on my sine line? Zeros, yep, exactly. Zeros first, which requires factoring because you won't have a calculator. But there is one on your worksheet where to get the zeros, it's calculator active. So what will you just do? Calc 0. Okay, but this one I can't do that because I would not have a calculator. So here's my function. Its zeros are in my face at 0 and at negative 2/3. All right, then what do? We plug stuff in to see what the concavity is because the second derivative will tell me. So I'm going to pick my favorite number over here, number negative 10. I'm going to plug it into the second derivative. I like to plug it into the factored form because I don't care what it is, I just care about its signs. When a negative 10 goes in, that will be negative. When a negative 10 goes in there, I'm going to have a negative. That will be positive. That tells me my original function was concave up. It was part of a cup. It was either concave up and decreasing or concave up and increasing, but I don't care which. All right, next step, I'm going to pick my favorite number in here, maybe a negative a half. I'm going to plug it in and I'll have a negative leading here, but then this will balance out to be positive and I'll have a negative. So it changed concavity. Hey, you remember what that's called at a concavity change? Inflection point. Oh, your memories are awesome. Then I'm going to go pick my favorite number over here, 2 billion. Oh no, 1.3 billion. Because I'm going to win. And I'm going to buy an island. Yeah, I'm going to call my island Sandy Shores. Because that's my name. I am. It's so fun. And the way I figure it is that I have a really good chance of winning because you either win and you lose, and that's only 2 options, and one of them's right. So I figure I have a 50% chance of winning. Is there something wrong with that math? That's right, isn't it? If I buy 2, then I'll win for sure. Well, then I'll do that. Just kidding. Ha! Anyway, where was I? Oh, I was doing 1.3 billion is my favorite number, which will be resoundingly positive. Now to answer the question, because this would be FRQE, so I need to make sure I answer the question. This is not an answer. It can't even be part of my answer, by the way. Anytime it says justify, it means with a sentence and with words. You don't point at graphs or circle sign lines. You justify yourself. You say, it doesn't have to be a formal and perfectly constructed sentence, but you say concave up. If you want to have proper grammar, you would say y is concave up, but you don't even need to have complete sentences. You just need sentences. Concave up on negative infinity to negative 2/3, a union with 0 to infinity, not because I'm going to point at my sign line or circle my sign line, but because with words, because there's sense, how do I complete this so I get full credit? Since you about got it. Y double prime greater than 0. This right here gives you a gold star. This won't even be looked at. College Board is very specific that they don't look at graphs, sign charts, diagrams, nothing. They just read your words. All right, are we done? Answer is, I hope so.